Basic financial functions using the Texas Instruments BAII 2 Plus financial calculator. Our problem is deposit $200 at the end of every month in an investment that pays on average 6% per year effective yearly. This is equivalent to 5.841061% compounded monthly. What is the future value of the payments in 20 years? The mathematical solution is as shown. The calculated solution is as follows. We first press second function, p/y. This enters a menu where you enter the payments per year and the compounds per year. In this problem, the payments per year are 12, since the payments are every month. Press 12 for p/y, and then press enter. You know the value has been entered when you see an equal sign. Press the down arrow button. The display changes to c/y, which represents compounds per year. Since this is 6% per year effective yearly, the compounds per year is 1. Press 1 and press enter. We've now set our calculator to 12 payments per year and 1 compound per year. We leave this menu by pressing second function, quit. The third row of buttons is the TVM, or the time value money buttons. The N is the number of payments. 12 payments per year for 20 years is 240 payments. 240, and then you press N. The interest per year is 6% per year effective yearly, so press 6 and I/Y. The calculator will automatically convert 6% per year to 5.841061% compounded monthly as per the mathematical solution. The present value is 0. The payment is $200 at the end of every month. 200. We change this to a negative just so that the calculator knows that this is money going out. Press PMT, $200 per month. To find the solution, we compute by pressing CPT and the future value. And the answer is $90,687.73. What is the present value of payments of $1,000 at the end of every 6 months for 6 years if the rate of interest is 5% compounded monthly, which is 5.0523774% per year compounded semi-annually? The mathematical solution is shown. The calculator solution is as follows. We first set our calculator to payments per year and compounds per year by pressing second function, PY. The payments are at the end of every 6 months, so in this case, there are 2 payments per year. Press 2, press enter for p/y. Press the down arrow button. The compounds per year. The given rate is 5% compounded monthly. This means that there are 12 compounds per year. Press 12 and press enter. We have set our calculator for 2 payments per year and 12 compounds per year. We leave the menu by pressing second function, quit. The payments are every 6 months for 6 years, which indicates that there are 2 payments per year for 6 years or 12 payments. Press 12 and then press N. The interest rate is 5% compounded monthly. Press 5 and press I/Y. Again, the calculator will convert the 5% to 5.0523774% compounded semi-annually, as we have set our C/Y to 2. We are looking for our present value, so we leave that for the end. PMT, 1,000, negative for payments. Press PMT, 0 future value. In this case, we compute our solution by pressing CPT and PV for present value, $10,241.52. This is an example of a due payment or an annuity due. A car is leased at $50,000 for 4 years at a rate of 5% compounded monthly. What are the monthly payments? The payments are at the beginning of the month. The mathematical solution is as shown. Press clear. We can clear all of our work by pressing second function, clear work. Since this is a lease problem, the payments are due at the beginning of the period. So we set this by pressing second function, BGN, which is the same button as PMT. You will see N, which indicates that the calculator is set for end of the period payments. We can change this by pressing second function, set. This changes it to BGN or begin, beginning of the period payments. We leave by pressing second function, quit. We know our calculator is set for annuity due type problems if you see a BGN at the top right hand corner of your display. Since the car is leased for 4 years and the payments are monthly, there are 48 payments. 48, press N. The interest rate is 5% compounded monthly and the payments are monthly. We set this by pressing second function, PY. Monthly payments, 12. Payments per year, press enter. Down arrow. The compounds per year changes automatically to the same as the payments per year, so there's no need to change this unless it is different. So CY is also 12. Second, quit. The payments are monthly for 4 years, so 48 payments. Press N. The interest per year is 5%. The present value is $50,000. The future value will be 0, 0, and FV. And we compute the payment by pressing CPT, PMT. $1,146.69. The negative just indicates that it is money going out. Clear. Second function, clear work. A $500,000 mortgage amortized over 25 years at 3% per year compounded semi-annually. The payments are at the end of the period. Compute the monthly payments. Again, we need to change our calculator this time to end of the month payments. Second function, press begin. Our calculator was previously set to BGN, so now we will reset it to end. Second function, set. We leave by pressing second function, quit. The BGN has disappeared, which indicates the calculator is set for end of the period payments. The mortgage is amortized over 25 years at 3% per year compounded semi-annually. So we need to set our payments per year and our compounds per year since we're looking for monthly payments. Second function, PY. The payments per year monthly. Press 12. Press enter for PY. Down arrow. The compounds per year. You are given 3% per year compounded semi-annually. Semi-annually means twice per year. 2. Enter. Second, quit. 25 years, monthly payments, 300 payments. 300, N. The interest rate is 3% per year compounded semi-annually. Press 3 and I/Y. The calculator will convert to 2.9814201% compounded monthly. The present value is $500,000. Press PV. The future value is 0. Press FV. We compute the payment. CPT, PMT. The payment is $2,366.23 per month. Again, the negative indicates money going out. An amortization of $700,000 with terms of 6% per year compounded yearly is repaid with end of the month payments of $4,305. How many payments must be made? 6% effective yearly is equivalent to 5.841060678% compounded monthly. The mathematical solution is shown below. The calculator solution follows. We set our payments per year and compounds per year. Second function, PY. There are 12 payments per year since the payments are end of the month payments. Press 12 and press enter. Press the down arrow button. The compounds per year. The given interest rate is 6% per year compounded yearly, which is once per year. Press 1, press enter. We have set our PY, payments per year, to 12 and our CY, compounds per year, to 1. We leave this menu by pressing second function, quit. We are looking for N, so that is the last button we will press. The given interest rate is 6% per year compounded yearly. Press 6 and press I/Y. The amortization is in the amount of $700,000. $700,000, and that is the present value. The payment. The payments are $4,305 at the end of every month. 4305. Change that to a negative since it is money going out, and press PMT. 0 for the future value. If you want to review, press recall, I, 6, recall, PV, 700,000, recall, PMT, negative 4305, and recall FV, 0. Press compute and press N. There are 322.85 payments, which we round up to 323 payments. What rate of compound interest effective yearly would be needed to amass a sum of $1 million over 35 years if savings of $1,258 were invested at the end of every quarter? The mathematical solution is impractical. The calculated solution is as follows. We first set our payments per year and compounds per year. Second function, PY. The payments are made at the end of every quarter, so that is 4 times per year. Press 4 and enter for PY. Press the down arrow button. The compounds per year. The answer that we want would be effective yearly, so that would be once a year. So press 1 and press enter. We've set our payments per year, which is 4 every quarter, and our compounds per year to 1. We leave by pressing second function, quit. The payments are made at the end of every quarter for 35 years. So 4 times a year times 35 years, press N. Since you're looking for the interest rate, this would be the last button that you would press. The present value would be 0. 0 PV. The payments are $1,258 every quarter. 1258. We make this a negative since it is money going out. Press PMT. $1 million is the future value. Press compute and press IY. The answer is 8.50% effective yearly or compounded yearly. If you want a more accurate solution, you can set the decimal places to whatever you desire by pressing second function, format, for example 6, and press enter. Leave this menu and then compute IY again. 8.499746% compounded yearly. Converting interest rates. What is the equivalent compounded yearly interest rate, i.e. effective yearly, to 4% per year compounded monthly? The mathematical solution is shown. We do this by using the ICONV function, which stands for interest conversion. Before we do this, we will set our calculator to 9 decimal places by pressing second function, format, which is the same as the decimal button, press 9 to set 9 decimal places, and press enter. Then we leave, second, quit. We convert by pressing second function, ICONV or interest conversion, and the interest conversion window pops up. NOM stands for nominal interest rate. The nominal interest rate in this problem is 4% per year, compounded monthly. Press 4, then press enter. Press the up arrow button to go to C/Y or compounds per year. Since it's 4% per year compounded monthly, I know that there are 12 compounds per year. Press 12, press enter. Press the up arrow button. The window will show EFF, which stands for effective interest rate. In this case, effective yearly. We press compute. The effective yearly interest rate is 4.074154292%, effective yearly. Next question, what is the equivalent compounded semi-annual rate to 8% per year compounded monthly? Let's clear everything by pressing second function, clear work. We start with 8% per year compounded monthly. Press 8 and enter. For nominal, press the up arrow button. The compounds per year should be 12. If not, press 12, press enter. Press the up arrow button. We get to effective again. We need to convert to the effective yearly rate first before we convert to any other compounded rate. So we press compute to compute the yearly rate. The yearly rate is 8.299950681% compounded yearly or effective. I need to convert this to the equivalent compounded semi-annual rate. Semi-annual means 2 compounds per year. So I press the down arrow button to go back to compounds per year, and I change this to 2 now. Press 2 and press enter. Press the down arrow button to get back to nominal. We originally started with 8% per year, compounded monthly. We now press compute, and the calculator will convert to 8.1345246% per year compounded semi-annually, since we set our calculator to 2 compounds per year.